And the third type of materials we use for aligners is resin. For direct print, we used to use 3 kinds of resins. It's terahertz from Graphy, terahertz TC85, TA28, the new one, and Lux Creo. It's a separate brand. What are key features of directly printed aligners? They have the same thickness at each part of an aligner. We can design the aligner's shape, and usually we just set the thickness at 0.5 millimeters so that we have a homogeneous structure of the aligner. It's 0.5 at every part of it. And it makes it stiffer, it's much more solid, it's less flexible than regular aligners. But the key feature of these directly printed aligners is the membrane shape feature, their thermoactive membrane shape. So this aligner, it was printed in our lab. And let me show you what happens if we soak it in hot or just warm water. It's going to restore its original shape quickly. So same process happens in the patient's mouth, but more slowly. Obviously, it takes about 1 hour for the directly printed aligner to restore its original shape by 90+%. And when the aligner is heated, it becomes very, very soft. And you can put it on a very curved teeth. We can increase the step from 0.25 to even 1 or 1+ millimeters per each aligner. So we put the aligner on the dentition and it becomes solid again, and it starts to restore its original shape slowly and painlessly, moving the teeth to the desired position. And we've tested 3 different materials. The one I'm holding in my hands is Graphy, the old one, TC85. It turned out to be toxic, and we see the toxic reactions frequently in our patients, so that we discontinued using it. The new material from Graphy, it's called TA28, and it's a promising one. It's more solid and less flexible. And the problem with the old one was that we had breakages quite frequently, complaints from the patient that the aligners break in less than 2 weeks. And this problem should be in the past with this new material. And yes, and it also has this memory shape feature, so we're starting to test it. And these aligners are made of Lux Creo. They're much more flexible at the first glance, and they feel more like conventional aligners made of polyurethane. But they also have this memory shape feature if we soak them in warm water. We can also change their shape drastically, and they keep it, starting to restore the original shape once be put in to the temperature equal to around 37 degrees Celsius as the human's body temperature. So this technology is still very new, and for commercial aligners, we used to use the conventional materials like PETG and polyurethane. And with the directly printed aligners, we use them for our own patients in our clinic because we still don't know all the properties and the capabilities of these materials. They look very promising, but they still require a few years of clinical trials. Graphy, they also produce a lot of interesting things for printing. There are directly printed crowns made of their material, some splints and night guards, sport guards. So we also implement this to our clinical routine, and all this stuff looks very promising and interesting to me. So I recommend you to try this method of aligners production, the direct printed aligners, so that you can increase the capabilities of aligners and treat more complicated cases, because when you can vary the thickness of an aligner, you can make them to produce more bodily movements. You can try to play with crowns and root torque. So this technology looks very interesting, and I'll keep you updated with my newer cases made on Graphy and Lux Creo resins. Thanks.